of the driving and compelling reason is the power utility efficiency. So it is very essential that we understand the metrics related to the PUE. So power usage effectiveness is using the source that the energy consumption, and it is essential that you need to understand and see what are the ways in which you are able to drive the power usage effectiveness. And as I said, a lot of agencies which are driving this, and one of the initiative that started a couple of years was the Green Grid, which is again a non-profit organization which saw the various trends within the data center space where power consumption was too high, and what are the matrices that can be brought into the operational system and help in managing. So the Green Grid, the 7/24 exchange, the ASHRAE, which is from a cooling perspective, that's another organization which talked about the PUE. Then we have the Silicon Valley Leadership Group. Then we have the US Department of Energy, Save Energy Now, which is part of now the Save Energy Now program. Also the US Environmental Protection Agency, which is the Energy Star. So you would have seen in a couple of equipments, a couple of manufacturers now emphasize on the Energy Star. So that's another PUE-driven perspective. Also the Green Building Council. So there are Green Building Council across the globe, started in the United States as United States Green Building Council. And then regionally we see many of the countries have adopted the Green Building Council, and they have started their own chapter within the region. So the the United States Green Building Council also put their efforts in the PUE. Again, in the last session in the hall 2, we saw representatives from both Uptime as well as TIA. So that's another organization which also emphasized on the PUE. Now, PUE and what are the metrics? So as I mentioned, the total data center energy consumption or the power consumption within your data center is what your PUE is derived of. And there are guiding principles. The Green Grid started this when as a non-profit organization. Even today they are a non-profit organization. There are a lot of members who, as a initiative in their from their experience that they have gained, are able to provide support to the Green Grid Council. And these are all volunteers who have come with the experience that they have gained in the various fields, be it the power, be it the cooling, or any field, and they have come forward and they've given their recommendation. So this is compiled, and based on the Green Grid nomenclature, there are various categories in which it's been determined. The PUE, basically, it's the PUE X is represented by the 0, 1, 2, and 3, which is basically the various categories in which it falls. And so PUE is the total facility power divided to the IT equipment power. So that's the equation for the PUE. And today, as I said, it started with the non-profit organizations all gathered together for a common cause, helping the facility managers or the IT team to reduce the operational cost. And with that perspective, today it's not just the non-profit organization who are talking about. It's now part of the ISO standard itself. So ISO 30134-2 emphasizes on the PUE, and going forward, it's driven by the standard itself. So if you want to have an effective PUE, you need to ensure that you also meet with the ISO standard for the PUE. And the part 2 of it talks about the PUE within the ISO standard. So where and how can you measure the IT power consumption? So if you look at your architecture within your power distribution, it starts. So I'm starting from the UPS point of view. Even prior to that, you have your the source of energy which is coming into your facility, and then your switch gears and various distribution. So from the IT perspective, from the data center or the critical space perspective, so we are starting from the UPS. So the UPS output goes to your floor-mounted PDUs or the floor distribution switches, and from there it goes to your end equipment, which is your IT load. So you would look at various aspects. You have an opportunity for you to look at the options where you can measure. So be it at a floor PDU perspective or where the power outlets are there. So you can see the power can be monitored from a more organized. So in a couple of slides I would talk about the more organized way of distributing the power. Which is using a flexible power system, and you are able to see. So if you see, it can be measured or monitored at the end feed or at the plug level, which is connecting to your PDUs. And also you have your intelligent PDUs, which also have the various capacities to measure each of the IT loads that are connected, or each of the IT equipments that are connected. So various locations where you are able to measure the IT load. So talking about the distribution, I just want to touch base on how the distribution has changed in the recent past. Our driving factor is the reliability and the seamless connectivity that you would need for each of the services that is employing the critical power. So if you have to look at it, you have the traditional power distribution, which is using all your row patch power panels, and then all your cables are lying below the raised floor and connecting to. So you have a source A and a source B coming from the various from your PDUs to your various equipments. And typically most of the distribution I have seen is below the raised floor. Now when you do it below the raised floor, you have a challenge of the whatever void space that is there below the raised floor is completely choked, right? So the airflow is completely blocked. So you end up reducing the efficiency within the cooling. So when the efficiency is reduced, the power consumption automatically becomes too high. So it is essential that these obstructions are completely eliminated. So the way in which you would do that is having so this is your traditional way. You have a service board, then you have a UPS, the PDUs, and then you have a sub panel, and then you have the individual cabinets which are connected. And today we are talking about a distribution which would help in more organized and more flexible way. So if when I say flexible way, your power needs to be available at any given point with whatever circumstances that is there, completely flexible. So you still have a service board, UPS, the PDU, and from the PDU, instead of going to a sub panel or the RPP, you are now eliminating with the feed unit, and from the feed unit, the bus bar is directly extending all the way to end of your individual cabinets. So which means you are now eliminating an other big space that is needed at the end of the row. One of the other driving factor is the space. We just heard that countries like Singapore, Hong Kong, and also now I just heard Dhaka is also not having that luxury of space, but whatever the space that is available, you are able to try and accommodate the critical space. So the real estate is a critical challenge. So if you are able to eliminate the sub panel, which is almost taking a cabinet space or two cabinets when you consider source A and source B, so you're able to eliminate two cabinet space and then utilize that for your IT equipment, you are able to have a good space for that as well. And so with that system, typically from Starline or from Universal Electric, we also provide, as I said, the engineering support, right from providing a 2D layout to a 3D layout, which helps in identifying what is your power distribution that is needed, and then help. So it completely gives you all the information in terms of what your components and how your system would look like. And From a Starline perspective, all of our product are, the housing is aluminum. We don't use any kind of a sheet metal, so it gives you a good grounding and also acts as an 100% protective earth. These are completely a track system. You could, there's a stall in the above floor, so when you get a time, you can just have a look at it. One of the track has been displayed, and also a couple of plug-in units have been mounted over there. So it's a track system, and you can see this is extending all the way across. So you just join the various lengths. So there is no restriction in what length you would need. So completely flexible in terms of what your requirement is. And this can be also closed with a closure strip. Wherever you insert your plug-in units, you are able to then close with the closure strip. The design is patented, and it gives you the flexibility of inserting when the power is energized. So, which means the power is available within your power distribution system, and then you are inserting your plug-in units wherever you need. And these can come in very small form factors. So what you're seeing here is a 800 amp system, and you can see 800 amp system. Typically, you would end up having a big bulky box, right? So we are talking about 800 amps, which is 163 mm, and height is 128 mm. So within that space, I'm giving you a 800 amp system, be it a 4-wire or a 5-wire configuration for depending on what your power distribution is. And these are finger safe, and these can be, as I said, can be done in a live environment. There are no bolt nut systems, so again, your maintenance that is needed over a period is also eliminated, and it helps in giving you a flexible power within the system. The critical element, we talked about the monitoring, so this can be provided at the plug level, which you see at the bottom. The plug-in unit itself with the monitoring, with display or without display, can be provided. Also at the end feed, we can also provide with display or without display. And this can measure all the critical elements that is needed, like from your volts, amps, watt-hour, frequency, power factor, and so forth. And as I said, can be available with display or without display, and can be integrated today. Everything, whatever monitoring system that you have, need to be integrated with your building management system or with your DCIM, which is your data center infrastructure management, so that the data is collectively available, and then you as IT managers or facility manager are able to take the necessary step in managing the system. And also all of this various systems can be integrated with whatever protocols that you need, be it from a Modbus to an SNMP to Wi-Fi. Again, within a Wi-Fi, your IEEE 802, or your wireless, which is using your radio frequency, can also be utilized. Also, there are a couple of instances we have seen. There are a couple of old systems like your BACnet. So our monitoring system can also communicate with your BACnet topology as well. And Starline is the critical power monitoring. As I said, you could see the various options where the Modbus Ethernet wireless communication all can be available as a plug and play. Even at a wireless, we also, as I said, using the IEEE protocol or with the radio frequency, we are able to give you a plug and play. So all you have to do is just insert, and once the power is available to the monitoring system, you are able to directly, it does the auto configuration, and then you are able to manage. So not much of a manual intervention is there. Again, reducing whatever the human error that could happen within your monitoring system. Also, the plug-in units, we have samples upstairs. These are completely tool-less design. Again, why? Within the critical space, when you are doing move, adds, and changes, when it is operational, any small components can cause downtime. So we have ensured that most of our components use less components or less tools, or completely try to eliminate the human error that could happen. So these plug-in units has a tool-less mechanism for locking, and you would see it has a gear mechanism. You just engage the lever, and the gears gets unlocked, and then you are able to manage it. So completely, you would see there are a lot of engineering that we put into the components that we provide. And as I said in the beginning, these are manufactured only in the US, and then we support across the globe for this product. And these are a couple of installations that we have done in the region. And again, there are a lot of customers right from a banking to a critical data center hosting company, colos, and also enterprise data centers. So many of them are there, and in fact, across the globe, we almost have more than 70% of the market share within the flexible power solution for the critical space. And these are a couple of our examples where you can see not only a small IT load to a large servers like the EMCs or the Hitachi storage. We are able to provide that flexible power, be it a single phase or a three-phase, combination of single phase, three-phase, or combination of multiple sockets, various depending on the region we are able to provide. So completely flexible. And these are a couple of our installation pictures just for the reference. You would see these are used in the very critical space. And yep, that's it. So this is what I thought of emphasizing on the critical space on the power monitoring. If there is any questions, I would like to take. Yep.
Hello.
Yeah.
My question is that we've shown that modular things. For installing those modulars, can it be installed at any given point, or we have to like start from the beginning and just slide it to the point?
Can you just go back to that slide, please? So if you come back in the hands-on, you would see
Yes.
it's not a sliding one because the power is available all across.
Yeah.
But what I meant is it's a track system, which means I'm able to remove it and then mount it anywhere. So there is no fix.
At any point.
At any point. Any
So,
point.
I want to insert like in between two of that. Like I have two. I'm going to insert here, one here.
Yep.
I can insert it in between.
Absolutely. As long as there is a space available for you, because the modules that you see are depending on what your configuration is. It can be dual circuit, dual three-phase, dual single-phase. Depending on that, the size varies, and accordingly you are able to manage it. So yes, it's a track system anywhere, as long as you have to. As I said, this is inserted in a live scenario. The load is disconnected because that is very essential, and then you are able to disengage.